All right, here we are. Another week, another hacking session. I'm Agent Ultra, and on this stream, I program things in functional programming languages like Haskell, pretty much most of the time. But not always. Sometimes we branch out and try other things. Thank you for tuning in and hanging out with me. If it's your first time checking it out, I don't know what to say. Thank you, but thank you. That's it. Thank you so much. So, the past few weeks, we've been working on trying to build a multi-user dungeon server. This is like a multiplayer online game where you connect with an old fancy mud client, a telnet client of sorts, and you play the game with other people in near real time in text. Kind of a bit of a theme. We've done a little bit of a text engine kind of game, but that was more of a single player sort of thing before. And this time we're going to do multiplayer. So check out Haskell's networking and its cool concurrency libraries and primitives, and have a bit of fun. So thanks for joining me. Let's get down to business. Last week, we got a bit of command dispatching working and a very rough, very first pass cut of like a command, like logging in and creating an account and stuff. So we're gonna continue on. I don't know. I'm thinking maybe I might work on adding either persistence to that and like rounding it out, or moving on to more things that I want to work on. I'm eager to work on, which are the just getting the Lua Haskell bindings working and getting like the actual game part working, and like getting that kind of stuff going, the fun stuff. So I might work on that part. I mean, all of it's pretty fun in some way. You got to find the fun in everything, right? But yeah, let's see where we're at actually. Let's see. So simulation, just broadcast hello constantly on a thread delay. We're gonna have to update this now to do stuff. And yeah, let's try and get some Haskell bindings. Ooh, we got a follow. Thanks you, Yui, for the follow. Appreciate it. Let me know in chat if you're a real person and if you like Haskell. Yeah, so I think let's try and get the Haskell Lua bindings going, because that's going to be pretty interesting. That'll get the game parts of things going, and we can round out the other stuff as we go along. Yeah. So I think this is the package that provides bindings and types to bridge Haskell and Lua. I've been kind of interested in using maybe Lua as like our mud script language for such a server as this. Only because hot reloading Haskell code, I'm not even sure if that's possible. It might be, but it would be a lot. It might be easier to do in Lua, and more people probably know Lua. So they could still use our server, even though it's written in Haskell, but they could write their own game code and build their own system in Lua. And then I get to learn something too, a little bit about, embedding languages like Lua and other languages in a Haskell system, in a Haskell environment, which I haven't done before. So, but I've done it in like C and stuff like that. So I'm a little bit familiar with Lua. But this will be interesting to try it out in Haskell land and see if we can make that happen as well. Okay, so let's figure this out. The Lua package with interpreter and bindings. Lua is it's a language, and it's pretty nice little language. But really, what's really cool about it is that it's easy to embed, at least in C programs, and pretty straightforward. As far as like I've used it, you just give it like a table with a bunch of initialize with a bunch of like a data structure with some function callbacks to your system, the environment, your system that you're going to run the interpreter in, and then Lua scripts can call those functions. Which is pretty cool. So we got Cabal build flags. All right. So if there's a locally installed Lua version, we can use that, or we can use a global one. Probably just use the package one for now. Package config. Allow unsafe garbage collection. Okay, I'm gonna leave that safe for now because of performance problem. We can try this out and make sure that this invariant holds. Okay. We'll read more about those later. All right, let's jump in. Okay, so it's getting very close to the CLua API. All right, so we should be okay, hopefully. However, there are important differences. The method for error signaling used in Lua, based on set jump and long jump, is incompatible with the Haskell FFI. All errors must be handled at language boundaries. This failure to do so will lead to unrecoverable crashes. Okay, hopefully we'll get some examples of what that looks like. C API functions can throw Lua errors. Well, that can throw Lua errors are still exported, but non-throwing HS Lua versions are provided as safer alternatives. The HS Lua ersatz functions have worse performance than the original ones, but should be fast enough for most use cases. Hopefully there will be for ours. Hopefully. Although, being a server and a multiplayer server, like, performance is going to be a thing we're going to be concerned with. Of course. I mean, we should, on some level, be concerned with performance for most things. Or at least be aware when we're making trade-offs for it. The Haskell FFI requires all C functions. It can call back into Haskell to be imported safely. Yes. Some of the Lua functions may directly or indirectly call Haskell functions, so they are always imported with the safe keyword. Okay, many API functions can trigger garbage collection. This will lead to problems if Haskell functions are used as part of finalizers. Okay, so meta methods, GC meta methods, okay. Haskell in finalizers is not supported by default, but can be enabled by unsetting the allow unsafe GC flag. Okay, that's probably because we don't want, like, the Lua interpreter objects getting mixed up with the Haskell objects. And references getting garbage collected out from underneath us and stuff like that. Okay, so we got our run Lua operations. Runs operations on a new Lua state. The state is created when the function is called and closed on return. The state and all pointers to values within it must not be used after the function returns. Actually, might get used after freeze and using an uninitialized memory and stuff, which is no bad. Run a small Lua operation, prints the major version of Lua. Okay. So with Lua state, L, okay, open libs with C string print. And then we have some Lua function to get stuff out of Lua interpreter, it looks like. And then a Lua p call. Stack index 0, okay. Alright, so you can reach right into the Lua interpreter through that. State is just a pointer. Very cool. Can we get it to call into... Can we give it Haskell functions to call into, or do we have to give it C functions? In order to communicate properly with Lua, a C function must use the following protocol, which defines the way parameters and results are passed. C function receives its arguments from Lua and its stack effect. The function starts. Okay. Push them on stack in the order. Okay, this is all in Lua C function. Okay, pre-C function. Okay. Okay. Type of Haskell function can be turned into C functions. Okay. Alright, so maybe there's a chance we can do that. Through the magic of Haskell's FFI. Okay, so a lot of stuff, stack helpers, state manipulation, stack manipulation. All right, so we're basically going to install some functions. We're going to call some user code and run it. So how do I do that? Push some Haskell stuff on. A debug interface, nice, okay. Push Haskell functions. Ah, yes, there we go. Sweet. Okay, so we can have a function like this, okay. Okay, cool. Stack-based interpreters. Fun, fun, fun. Sweet. Okay, so we can push Haskell functions. That's good. Okay. Some standard Lua libraries get packaged with it. Awesome. How do I... Obviously with state. How do I pass it some Lua code and run it? That's right, Code Pilgrim. Mud is in multi-user dungeon. Yeah, classic. Old school. Welcome to the stream, by the way. Thanks for the tuning in and hanging out. Have you played Muds before? Yeah. Hopefully once we get it good and far enough along, like, I'll be able to throw this up on a VPS somewhere and we can mess around with it on the stream. Have some fun with it. So we're gonna go status codes, yes, stack index helpers, Yeah, stack manipulation. Okay, maybe it's a different module. Maybe I'm missing something here. Primary call? It's going to do a little bit of that under the hoods. Cool. Fun. Okay. Let's call. Auxiliary. Oh, there we go. Lua load to load the chunk in the buffer, pointing to my buff. Blah, blah, blah. Okay, so presumably there's a higher level function, Lua load function that I missed. There we go. it doesn't run it. Good, loads the chunk. Okay. Some GC control. Okay, low load. Lua P call. Okay. Alright, that's probably what we're going to need there. So let's bring this library into our server. Let's get Lua load to load a chunk of, like, I don't know, some simple Lua code. And just check that get that all working, and then we just can expand out from there. Okay. So I'm gonna make sure I got all my recent code. System Carl, welcome to the stream. Thanks for the chat. How's it going? Yeah, we're gonna use Lua for the mud code. So we're gonna use Haskell as the underlying engine. Haskell's gonna run. We're gonna use that for like the entity component system, for like running, like doing all the networking, and running the code that the user is gonna write in Lua. That way, hopefully, I'm hoping we'll be able to get some hot reloading. It'll be easier for people to script and kind of build their game in, and we can have a nice high performance, fast server written in Haskell. Yeah. Mainly I'm doing this to learn how to, embed Lua in Haskell and play with that library, because I think it's pretty cool. Also, to like demonstrate Haskell's awesome concurrency primitives and networking support, providing stuff like this. And then to have a little bit of fun along the way, too. You know? I used to love playing on MUDs back in the day, and I thought it'd be a nice, fun, interactive way to, or interactive project for the stream. If we can get this hosted somewhere, run it sometime, get people playing it, and mess around, and I don't know, who knows? Maybe we'll get some Twitch interaction on the server and all that kind of stuff. We'll see. We'll see how far it goes. It's mostly a learning project, but we'll see. Could be great. Script-based like Hacker Mud. Hacker Mud is super awesome if you haven't played that one. If you like that kind of thing. This game here is sick. I love it. It's fun. You probably could make something like that in this, maybe. It's going to be pretty flexible. I think I'm going to ship like a kind of a demo game with it. With the repository, with the project, so you can have a starting base to work from if you wanted to make your own MUD server. And that sort of thing. So, let's get our Cabal file open. And let's get this Lua library imported and building. I don't know what version yet. Let's go 9.10.1. I think we're up there, around there, 2.3.3. Let's get the builder going. Let's use GHCID for now. Yeah, it's going to be more of the engine part. Yeah, for sure. So if you wanted to make your own hacker game, you should hopefully be able to do it. As long as you can describe it in the way we're going to represent objects and entity component system. I don't know that we'll have the ability to like have arbitrary user code in like restricted interpreters, but that would be a different kind of server. You might find a way, you might be able to figure a way to do it, or fork this or build your own from scratch in Haskell, because you'll be watching the stream and you'll get to understand why Haskell's awesome for building networked servers. Who knows? Okay. Ages Lua. So first things first, we have to import it somewhere. Let's do it in simulation instead of broadcasting hello all the time. We're going to you just import Lua. Yeah, client is not used temporarily, so I'll put that. Okay. Alright, so obviously the first one we need is going to be with new state. Now we're just going to try and get like the most basic thing we can do to work. Maybe we can even just start with this example here. What's this gonna do? Prints. Let's see if it actually prints anything. That's interesting. With C-string it comes from... Does it come from this library? It probably comes from the foreign libraries. Oh, it's a FFI, no, foreign string. Foreign.c.string. There we go. Now we have to lift IO a bunch of this. Status code. Okay, it returns a value to us, so we have to explicitly ignore. Okay, interesting. We're getting a type error of their example here. What's going on? This is an unsafe function. Errors will lead to a program crash. Consider using hslua get global instead. Okay, I will consider it, and I will consider that you're right. Thanks for the follow, Code Pilgrim, too, by the way. Appreciate that. Let's see. Simulation, 18, can't match a type. Okay. It wants C-string IOA, we got actual C-string for C-type size. Oh, it takes a few more arguments, this hslua version. What was it? hslua get global? Just missing a few arguments here. So it wants a C-string, a C size. Okay, it wants a pointer to a status code. Interesting. So this example doesn't compile. I'm not a huge fan of that. Maybe compiles like if you have your warnings way down. Try it out. Okay, so we need version. Okay, spam bots, we're getting those. You're gonna be banned and blocked. Okay. Get global. HS load, get global. So we just C size a pointer status code. Returns an IO unit. With C string. Takes a callback. C string to some IO action. So we could write this out this way. And that way, yes, we get the length of it and pointer. Oh, we want a C-type C size. Of course. And it comes from there. Yeah. And how do I get a C size? Takes a form. C dot types. It takes a word 60, wraps a word 64. I guess I can just wrap it in the constructor. Form.c.types. And that's going to be a form integral. Oh, fun. Okay. S here is a pointer. I guess we can't take this the length of a C string. We want the length of this, unless we have a size of or C string lang. Oh, there we go. Or into a Haskell string. No. With explicit length information. Okay, because C string lang has has the length with it. Okay, that's what we want actually. And something like that. C string len, you know. It's not exported, maybe? Oh, no, sorry, it's an alias. Okay. So I don't need, there's no constructor there. Or, my bad. Okay, that's good. Ish. We can get rid of the length. So we can just use slen. There, now we got our hole. That's cool. I like our hole. Our hole says we need a pointer to status code there. All right, so we make pointers with foreign.pointer. Zero. Can I get... a pointer to status code. Let me see, status code. Okay, I'll have to import Fortnite pointer. Okay, and we're gonna have to construct one. Oh, what was it? It's in foreign storable, I think. It is storable. Okay, so we can peek one, poke one, and create. Peek, poke. Okay, so we need a new pointer for our thing. Here. P, and is it like... No, I'll create a point or something again. Oh, it's been a while. Been a while since we're working on the Tiger Beetle library, and I had to touch that stuff. I think it's... Gotta create the pointer, and then we poke it with storable. But I can't make it equal anything. Like if I make this a pointer thingy that we want, status code. I gotta put something there to initialize it. Poke, 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 peek, peek, peek. So we need the pointer first, and then the A. I-O. La 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 la. Create a pointer. Haskell. Let's go, Google. There's Malik. Oh, that's right. Okay. Oh, it's kind of... Okay. Yes, and we use foreign pointer with foreign pointer to create one. Yes, okay. It's coming back to me now. There we go. Do we want to use foreign pointer for this? No, we're not going to keep it around for a long time. We just need it for this. One little bit. Yeah. So that function lives in Malik, Marshall.alloc. It's the very P I need. And that's not going to be a let binding, that's going to be there. We can use type applications to let inform what the type we're trying to parse, or we're trying to create the pointer for is. Just to hand you a little bit of syntax. There's a couple of ways to do it. I prefer this way if I can get away with it. So all it's going to do is we're going to just set what A should be when we call malloc so that we know what it should be. So this can be a status code. And then we can poke that with a value if we need to. But we don't. We're going to just pass it in here because that's all we need. Fill in that hole. We need to import for marshall.alloc. Right, hs lua is lua get global is unsafe. Yeah, you want us to do that again? Okay. And so we're gonna do the same thing for that. Slen 2. And then we're not. And we're all good. Let's see what happens. Let's see what this does. All right, let's run it. So we're gonna run our server now. If it's your first time tuning in, I've seen it before. Here we go. We're gonna run the server. We're gonna check it out. Yeah, I'm gonna open up my client first though. So I got a little handy dandy mud client we've been using for testing. Yeah, for some reason my VM is locked up. I don't know why it's locked up there. Go to the root of the project here. Cabal build. Or you go run Bakamud. There's a kill client. There we go. Okay, oh look at that. It's printing out the Lua version. Okay, so we're calling into Lua. Library is working. Lua 5.4. Sick. Alright, so that's going to go. I'm just going to demonstrate connecting to the server just because you might not have seen it yet, but we connect to it. We got our message of the day. Welcome Bakamud. We don't have any persistence yet, so our commands are like not a whole lot. We can register foobar to create a new user, and then we can log in with that one. Although apparently not. This was working. Oh, did I write foobar? I read foobar, that's why. Foobar, there we go. And you can log in. Right. Yeah, thanks System Carl. The P's and the B's, I don't know, you know? So there we go. And then from here, like, we can issue other commands. Login and register are going to be like system commands. They're going to be handled specially by the server, but like anything else you type, right, like like game commands, supposedly, will be this line here, line 69. This will be handed off to your mudcodes parser so that you can parse your own commands. Tell us what those commands are, and then or do what you need to do with your game loop and everything, and all that sort of stuff. But we'll basically hand those off. There's just certain special ones we're going to handle on the server, like registrations, logging in, authenticating, that kind of stuff. That sort of thing. So that's what we have so far. We're going to stop the server now. I gotta figure out what to do. Some of those clients, you might have noticed when I pressed enter there, it sent like this extra it sounds like an empty string for some reason sometimes, and it handles some of the clients when they disconnect does it a lot too. They send like a bunch of empty strings and then stop. I don't know why. We'll have to figure that one out. It's weird. I tested it with this client and with another one called Tintin++. That one does the same thing. Or when it disconnects, it sends a bunch of empty strings. Like just over and over again. Well, actually not even empty. I think they're just line control characters. Anyhoozle. Okay, so we got Lua calling. The example documentation in their documentations needs to be updated. Seems like. Okay, so now what can we do? The next little thing we could do is we could probably load some Lua code in and use pcall to call it and see what we can do from there. That's a tiny little step. So let's commit what we have so far in a tiny little work in progress commit. Add Lua code support. Okay. So that was the Lua code, I believe. Load. Well, it's funny that it worked even though we didn't pass it any status code. Actually, we just threw it a pointer. We didn't actually populate that pointer. If we wanted to put something in there, we would just basically poke a value from Haskell into that P. So when we malloc the P code there, poke P with our status code value, which might be Lua OK, say. And then call that. I don't know, maybe it's because it doesn't really matter for what we're using. We're getting just a global. If the status code doesn't matter. Maybe it matters for certain status codes, but not this one. Hard to say. Just check that works. Still. Foreign not storeable, I forgot to import that. There we go, yeah. Well, yeah, I don't know why it doesn't matter, but... Okay, alright, so let's put some Lua code in a byte string. Now I'm mixing up the B's and the C's, oh boy. And we're gonna need to import data.bytestring. Or we might be able to just do it with overloaded strings. That might just be fine, actually. I might not need to import that directly. Let's get GHCID back up and running. Okay, we'll need it. Okay, I think data byte string is a strict one by default. Okay. So a basic Lua program. Just print hello world, I believe. Braces. Okay. And I think we just need to call that load function. Lua load. Okay, we give it a null point, a void pointer to data, to our byte string, I assume, and a chunk name and a mode. We get a status code and return. Okay. Okay, so we're gonna need to maybe load this in a C string. In order to pass it across in this void pointer. Okay, so with C string, it probably just takes a normal string. We'll do it after here in our little program. We will, with C string length. Oh, we don't need the length. Code C. Okay, and a reader. Where do I get a reader from? See, Lua reader. Okay. Okay, so yeah, okay, so we're reading in code. Lua is going to stream in a chunk at a time using a callback from some buffer. Do they have some pre-made ones? That would be super helpful. Because that's going to be kind of funky to have to implement that ourselves. Looks like we might have to. Okay, looks like we might have to implement our own. That's not too bad. Not my favorite, though. I wish there would, like, a predefined one. Like a basic, like, just read until the end kind of thing. Those are the library functions. I know user data is a specific thing in Lua. Yeah, warn types, primary, okay. Yeah, reset, remove, replace. App. Okay. Looks like it's not defined. All right. So what we're gonna do is we're gonna get our code. Yeah, we're gonna do. No. What are we gonna do? Little load. Okay. Pass in our reader. Pointer to our data. Chunk name and mode. Our state is L. Something. Pointer to our data. So we're gonna have to. Can we pass C right in there? I think maybe. Hopefully, we'll see. We'll find out. A chunk name. Test. Mode. Don't know what to put in there. IO state is code. Okay. And presumably, we'll get some kind of code. Oh, too many arguments. State, reader, pointer, C string, C string. State, reader, pointer, C strings. Oh, C strings. Oh. C string, C string. Yeah, there we go. Okay. Perfect. Okay, so hold this reader. So that's a function. Function pointer. I'll call it load chunk. Type's got to be that. Leave it undefined for a moment, because I've got to pop that into fun pointer. And there's a way to do this as well. could do this as well in the Tiger Beetle code. Let me just look that up fast. Tiger Beetle chess source database. Tiger Beetle raw client. Callback. Find completion. Back. Yeah. Just like that, I guess? Is it really with the FFI stuff? It's more like, oh, okay. Yeah. And then when you call it, that's where you define it with this. This is the FFI syntax stuff that you get in Haskell. And then you can call this function to wrap a Haskell function. Yeah, but that gets called. And here, example. So that we call this is a function, or this here. Yeah, this whole thing. It's an anonymous function. A few arguments. And that's passed into our make completion callback, which turns it into a function that generates some C codes and C wrapper code stuff, so like C can call into it. So you can call into Haskell from C. So it looks like that's kind of what this is going to do as well, in order for us to create a function pointer to it that Lua can call back into, I guess. Unless there's, no, I don't think pre-C function would let us do that. Yeah, no, that's specifically for pushing on the Lua stack. Yeah, so we're gonna have to do this the raw way. Oh, wait, Maybe I have a better function here. Loads a buffer as a Lua chunk. This function uses Lua load to load the chunk in the buffer pointed to my buffer with size. This function returns the same results as Lua load. Well, maybe it does all of that for us. That would be way better. Okay, because I don't want to have to do that. Alright, get rid of that, get rid of that, get rid of that, get rid of that, close that, close that, okay. Lua load L. Or Lua L load buffer. Give it the state. Give it a pointer to our buffer data. We'll figure out how to do that. Size. A name. Test. And that's it. C string. Like that. Get rid of that. Okay. So now there's one hole we got to fill in with a pointer to a C charge as a C string. Allocate a C string, I guess. Can we do that with anything in here? No. Okay, so we'll have to malloc one. Alright, you can load it in there, in that hole at least. We got to set that data first before we use it, otherwise that's going to cause problems. And the C size as well. So I'm not going to do string. We'll do that back to byte string. And we need the null byte added to it in order to make that. We could do another with C string, I suppose, actually. And cast a pointer to it. This is only used temporary storage. Okay, no, C string length does return the pointer. Yeah, okay, so that allocates it. All right, that does allocate. Okay. So, new C string length is what we want for the code. Code pointer, code len. New C string len. code. Turn that back to string. And then C size will just be code len. And this will be not P, but code pointer. And we ignore P, Lua P call. Ignore results. Print results. Okay. Okay. If all goes well when we run this, we should see our hello world being printed, which really should be like hello from Lua. Okay, well, it's not printing to standard out, but it is getting status code 0, which means what, Lua? What does that mean? Status code 0. Right, it doesn't execute it. It just loads it, so it's loading okay. Right, we still have to P call. That's right. So then... arg 0, num results 0, stack index 0. Just do it. There we go. Hey, we're actually executing Lua code from Haskell. Awesome. Cool. Well, that's handy. Let's create a little commit for that. It's just test code for now, but we can get there. Okay, so good prog, good step. Now, what do we need to do? Now that we can run Lua code, and we can run a user program, and that user program in the simulation layer is basically going to run the whole game. We just have to provide data structures, functions for interacting with the server, and the rest is up to mud code. All right. So we could have maybe what can we work on now? We could work on like maybe loading the mud code and running it, and we'll just have like a simple mud code that just does this. But we'll load it from the file system and call it. And that'll be the start of that. Yeah. That's exciting. So we need data structures. We need the data structures we're gonna need objects, right? All that sort of stuff. We're gonna need the server loop itself. Like the loop itself will be called from the server, but we'll need to expose the tick value, the current tick, to the Lua code as well, so that user mud code can know like how long things have taken, are taking. And then, yeah, all the functions to like broadcast things to users or send things to users. And also ways for the simulation to, for us to know what's going on in the simulation. Like telemetry, observability types of things, debugging and stuff like that as well. Debugging hooks and whatnot. So that'll be cool. Awesome. All right. So let's do, how do we want to load the code in the simulation? Well, simulation shouldn't be doing really any of that stuff. We have the server, server state. So we'll have to have some way of storing the user code and loading it up into here so we can access it. And then the simulation can get it from the reader here. I have no hard ideas on how to organize the user's mud code. Right, we could do like one... Obviously one file is not going to be very nice because you want to be able to split up things in files. And I don't know if Lua has a way of importing other Lua code at runtime, so that you could define your own files and we don't have to tell you what those files are going to be and have to be. So let's look that up. It would be more like Lua language reference. Modules. Okay, require. All right. Okay, so we're gonna have to load in your modules for you, right? The engine's gonna have to load in all the modules it finds in the mud code, wherever the mud code directory is, into some kind of table that we can then load into the state of the Lua interpreter under a bunch of module names. And then you can use the modules, the require stuff, to require your modules. Right, that's what it looks like we need to do. Okay. Right, here's a loader, package table, loads a given module, starts by looking into the package.loaded table to determine whether module name is already loaded. If it is, then require returns the value stored in package.loaded. So like a cache. Otherwise, it tries to find a loader for the module. To find a loader, it's guided by the table package.searchers. Each item in this table is a search function that searches for the module in a particular way. By changing this table, we can change how require looks for a module. And the following explanation is based on default configuration for package.searchers. First, it queries package.preload module name. If it has a value, this value, which must be a function, is the loader. Otherwise, requires search as Lua loader using the path stored in package.path. If that also fails, it searches for a C loader using the path stored in package.cpath. If that also fails, it tries an all-in-one loader. Oh my gosh, so many different ways to load code. Once the loader is found, require calls the loader with 2 arguments, module name and an extra value, the loader data. The loader data can be any value useful to the module. For the default searchers, it indicates where the loader was found. If the loader returns any non-nil value, require signs return value, if the loader does not return non-value. Okay, so returns final package loaded module name. Besides that value, require also returns the second result, the loader data returns. Okay, so some function is going to go look. Some function of some type, I don't know. It's going to load some Lua code that's going to get cached in this thing under a module name key. Okay, but it has some default loaders, it was saying too. So you might be able to... It might have its own way of searching your paths, so we might not even have to do a whole lot there. Initializes variable value of the path before the path, or default path defined in LuaConf. Okay, so it looks like maybe all we need to do here is load in our own, just load in the main module, the base one that starts. And so long as this environment variable is set, and maybe the server could take care of setting that so that it looks in the appropriate place, Lua's runtime will, and loader stuff and search stuff will handle all of that for us. So if you want to require other modules and write your stuff in a more modular fashion instead of one giant file for all your mud code, that would be so cool. Okay. So all we need to do then is just have that path to that file, or yeah, maybe a path to the file in the state, and then a function for getting it and loading it. I'll call it mud code, mud main path. Maybe. I don't know, chat. Seems like a weird name. If you can come up with a better one, let me know. And file path, not path. I think it's file path. Yeah, file path. Okay. I'll leave a little comment on that one. Main user mud code module to start. Simulation. Yeah, okay. And then a simple little function, get reload, load is a pretty good verb for that. Read is a good one too. Loads mod main. No, let's not define it here, no. That can go in server. Server under mod code. Bakamud.server.modcode. This is where we'll handle all of the user code stuff. Maybe I'll call it load main, I don't know. It's going to be a Bakamud. Monad.io m. It's going to be a Bakamud action. Bakamud sir m returning a byte string. Maybe. I'm not super happy about using string generally in Haskell programs, but kind of limited a little bit. Maybe there's a better way of doing it. I'll find it if there is one. So a couple of imports we needed to get. Bakamud server monad to get Bakamud server, and monad.io.class for monad.io. We're doing okay on time. Okay, so main path. That's the one we want. Gotta get GHCID running, of course. This module isn't going to be loaded yet because I haven't told Cabal about it, but we will in just a second, I guess. Code. Okay, then we need board control, monad reader for that function. And we need server state. There we go. And let's just read. Read file. So we have to lift IO that. That's not initialized here. value for that. They're gonna have to pass it into us. We can't figure it out from here. Okay, we compile. But we're not done yet. We go back to I still don't want simulation to call load main because that's an unnecessary IO action. And we're going to be calling this in a loop. So I want to call it once and pass it in. We have to go a little bit lower. Go to the network layer where we start the simulation thread. Here. We have to pass it in there. Pop it in there. I don't have to recur that argument every time. You know what? Actually, yeah, simulation can do it. We're just going to break out the loop part and run that separately. So I'm going to walk back on that a little bit. Get rid of that, get rid of that. Just get rid of that. That. That's fine. And we have to add the Bakamud mud code. Mud code module. Okay, and instead, I'll call it tick maybe. It's gonna do this. So it's gonna call tick, and we're going to load the main function into Lua before we call tick. So we need this little nugget of code here. Right? But instead of code here, we're gonna load the code maybe up here. Based on what we called it. Load main. Now we're gonna get that from mud code. What have I done here? Yeah, okay. So instead of code, we're gonna do mud main module. Okay, we're gonna call this main. And that loads the module. And then we call tick. We should probably check the result, of course. Our status code types. Oh, there's a pattern instance on it. Where is it? There we go. So basically we want any of these, if it's not okay, then we want to report some kind of error. So I'll just crash the server for now. Fact. Else, Oh, maybe I don't catch it here. Maybe the right place to do it is a load buffer here and catch it here. Because then if result is not equal to okay, we're letting mud code aborting. Else tick. No, C programming. Okay, so then we tick. When we tick, we can do stuff. I'm going to get rid of all the test stuff. We're just going to p-call, for now, just the main module function, which isn't going to do anything terribly useful. Except we got to pass in that state. No, we have to do the call to tick in there, which in order to keep the L, in order to keep the state. That could be tricky. Is there a way to persist the state so that I can split up my code a little bit here? Can't be used after the function returns. Yeah. Well, we could run tick as a Bakamud server function. We have a way to execute those. We could just pass in the state that we already have so we can run it in this IO context. Okay, let's move it in. So we gotta go to this function here. We give it the existing server state. Asking for it. Which will need controlled on one-hand reader. Oh, sorry, not ask, var state. then we're going to get dependency errors. Hmm. Wait, this is having the problem? Interesting. Wait a second. This might be a bit weird. Okay, let's just hang on. Yeah. Okay, but state exists. Need more space. Okay, it is a server state. Okay, yeah, so it is bound in scope there. Okay. That's going to be an annoying, that's going to be a tricky problem to solve. Hopefully not too tricky. So we have to do everything within this new state context, which is an IO. And if we try to do like a Bakamud action, a Bakamud server action, that's not an IO, so it's not going to just work like that, right? We can't just run tick here. Uncomment tick. Right, if we can somehow pass a state in here. Right, it's not going to be too happy about that. So even if I could pass in the L here. Yeah, it's expected an IO action, but it's actually got a Bakamud server, because that's the type of tick. We could change tick actually to IO, maybe. Maybe we don't need the Bakamud server part. And then I have a redundant constraint here that we don't need. Okay, maybe that'll work. Ish. Where it won't work is if we need to actually, like, call back into the Bakamud server to update state and the server state from the user code. That, unfortunately, isn't gonna cut the cheese. That's not the right one. Cut the cheese. It's not gonna cut it. So we don't need lift IO there anymore. that through. Or that. Don't need this. Don't need that. Okay. Don't need that. All right. Now, the state needs a file path, which means the app, which GHCID isn't running, needs to pass that in. We'll call it main.lua. I'll hard-code it in there for now. I'll create one here. And I'll just call it hello from Lua again. And then, hopefully, this all compiles. And works and runs. Okay, we might be getting something going on with tick, maybe not. Running? Because code, pointer, no, sister name. Yeah. Just put that. It's okay, so it is loading the file. And if we put that there. So we're printing out that string. Our p call to Lua isn't executing our function. Maybe. Let's check the results. Status code 2. Runtime error? Yeah. Runtime error, okay. Runtime error with the P call. That's okay. We probably, maybe we just haven't, maybe I forgot to initialize the stack. called that, which initializes print stuff. Ah, there we go. Perfect. Okay, it's calling, but it doesn't appear to be looping. Okay, well, kind of working. We got code calling from Lua, but running out of time for the stream this week, so we're going to call it here. Clean that up. We'll ignore the result explicitly for now, but we should probably do something about it. Okay. And figure out why the loop isn't looping. So I'll try and work on that, but we might do it on next week and try to debug that and figure it out. But let's get this going. Do I want to commit this test program here? For now. Just so that it works. I'm going to get rid of it later, though. Alright. Alright, let's rebase all of this. Squash it all down, reword that. Okay, added. Move it later. Changed. Alright, simulation just runs mud code. Simulation no longer broadcasts on a loop. Just runs the mud code for now. Okay, I'll push that up. Thanks for tuning in. If it's your first time watching, I'm Agent Ultra. All the code you've seen tonight for this project lives on GitHub for now. I'm Agent Ultra on GitHub as well, and in most of the places. This has been Bakamud, an attempt to write a mud server in Haskell. And this is where it is. So you can give it a star, like, fork, whatever you want. It's all there. It's open. You can follow me on the socials. I'm on types.pl on Mastodon in the Fediverse. And you can follow me there to get updates on this stream, general technology. I try to content warn stuff that isn't kind of programming related, except for my awesome Inktober posts. Anyways, what else? Check out the site above my head, Discord, or not Discord, declarative.tv. It is a cool website where there are other streamers who are also doing things in languages like Haskell, but also Elixir, Erlang, and other declarative style languages. And there's a link to a Discord server on that website where you can hang out here, because we have a chat channel there. We have a channel where you can chat and, you know, ask your questions. So if you're watching this on my YouTube channel where I back up these VODs and you have a question or you want to ask something later, or you just want to hang out with other like-minded folks, join us there. It's a good time. I could always use a little more noise. And that's all I got for this week. Thanks again. I do these streams on Tuesday evenings at 10 after 8 in the Eastern Standard Time Zone. If you are cool like Code Pilgrim 0 and others who have followed me here on Twitch, give us a follow and you'll get notified if you have your subscription set up to when I go online. Or if you're watching from my VODs on my YouTube channel, give me a like and a subscribe and leave a comment, and that will also hopefully set up your notifications and you'll get notification when I upload a new stream. That's all I got. May all your monas be free and your types always check, and happy hacking out there. Take it easy.